Hello guys, I hope you are all doing well. In this video, we are going to continue our lectures on solving gate questions on C programming language. Our topic will stay the same, that is pointers. So let's begin. Now our first question is written here, in which we have to tell the output of this line. Now first of all, it is written static int a, and then an array is created here. So when an array is created, we can represent it something in this form, right? So the first value is 10, then it's 20, then it's 30, 40 and 50. Now the base address can be represented using the single character, that is a, right? And this address will be a plus 1, and this will be a plus 2, this will be a plus 3, and this will be a plus 4. Right? Now, if I am considering here, let the base address be 4080, and the size of integer, let's say it is of 4 byte, right? And size of address, let this be of 8 byte, right? I am considering here this just for the explanation purpose, because this question is pretty complicated, right? So now if we see here, this 10 is an integer, right? So how many bytes do I require to store an integer? That is 4 byte, right? So the next address will be the 4 plus the base address of our array. So this will be, the address will be 4084, right? Similarly, 4 again will be added, and this will be 4088, then it will be 4092, and then this will be 4096, right? You can consider here any base address. Why there is an increment of 4? Because we are holding inside the memory location, we are holding an integer, and size of the integer is of 4 byte, right? Since 4 byte will be taken by our integer variable, and the very next location will be after the 4 location, okay? Now it is written int asterisk p, and then the addresses. Now basically this is the array of pointers. Now this could be represented again in this form, in which first we have the address of base address, which means the address of this location, then we have a plus 3, then a plus 4, then a plus 1, and then a plus 2. So here if we see, these locations were holding values, right? Values. But here the locations are holding the addresses, right? So now let's say the base address could be represented by using p, okay? The base address of the array of pointers, right? Then the next address will be p plus 1, p plus 2, p plus 3, and p plus 4, right? Now consider that the base address is 3020, right? Now how many bytes are required to store this address or this value present here? Now basically this is an address, and to store address we require the 8 bytes, right? So if I do p plus 1, then 8 will be added to our base address, right? So this will be 3028, and then it will be 3036, then it will be 3044, and then this will be 3052. So this increment of the addresses is according to the kind of thing that it is holding, okay? So this was here we required the 8 byte to store the addresses. Now it is written a here. So basically if I write here, let's say printf of, let's say %u, and then I write here asterisk of p, right? It means that what is present in this address. Now asterisk p means what is present in this address, which is a, which means it will give me output as 4080, right? 4080. Now instead of asterisk p, if I write here, let's say simple a, then it will also give me output as 4080, right? So we can say that either I write here asterisk p or either I write here a, both are pointing to the same memory location, or we can say there is some sort of memory location and which have the address 4080, and either I can, to access this, I can either write a or I can write asterisk of p. Both will give me the memory address, okay, not the content. Now if I want to find the content, then what we do, we dereference it. So if I write here printf, let's say %u, and I write here asterisk of a. Now asterisk of a means what is present in this address. So what is present in this address, okay. So now asterisk a will give me output as 10, okay. And similarly this is an address, and then if I dereference it again, asterisk p, it will also give me 10, okay. So to access the value, I can either write asterisk a or I can write asterisk p, okay. Both will give me 10 as an output. Similarly, to access this memory location, or we can say 4092, I can write here a plus 3, which will give me address as 4092, or I can write here asterisk of p plus 1, asterisk of p plus 1. Now why asterisk of p plus 1? Because asterisk of p plus will tell me what address it is holding, and it is holding the a plus 3, right. So both will be pointing to the same memory location now. And if I want to access this address value present in it, a plus 3, then I can write here asterisk and here a double asterisk, okay. So in general we can say that inside it these are holding the addresses of these locations, right, the addresses of this location. And this addition of 8 and 4 bytes is just for explaining what will be the output if we increment the address by 1 or 2, okay. Now it is written double asterisk ptr equals to p. Basically it means that we can also divide this sentence into in these two parts, right. Int double pointer p, and then p equals to ptr, and then ptr equals to p, right. So basically there is a double pointer which will have its own address, okay, and currently it is pointing to this location, okay, address of this, right. So if I write here, let's say ptr is pointing to p. If I do %u of ptr, then it will give me output as 3020, right. And now if I write here, let's say %u, and then I do %u of p, it will also give me output as 3020. Now basically for this memory location, either I can access it using p, or either I can use ptr to access this memory location. So both are the right ways, okay. Now it is written ptr plus plus. Basically it means that increment the address by 1. So ptr was before p pointing to the p, and now it will point to this memory location. So we can say here ptr will now be pointing to the address of, either I can write p plus 1 or I can write here 3028, okay, because now we are incrementing the ptr value by 1. Now in the final it is written ptr minus p. Now from the pointer arithmetic we know that whenever there is subtraction of the addresses, the formula is address 1 minus address 2 divided by the size of address, right, or the size of the variable in general we can say. So ptr minus p, it means that first we will see what is the address holded by the ptr. It will be 3028, right. Then we have address of p. Now p is holding the address as 3020, right, 3020. Then divide the size of that variable, okay, size of, basically we divide with the what it is holding. So currently it is holding the addresses which is of 8 byte, so we will divide it by 8, okay. So this will give me output as 8 by 8, which will give me output as 1, okay. I'd consider here the size to be 8, but even if you take as 4 byte or 2 bytes, the answer will be same. Then it is written asterisk ptr. Basically this will give output as 1, and then it is written asterisk ptr. Now let's see here. First of all ptr, right, ptr is giving me the address as 3028. Asterisk ptr will give me what is present in this address, okay. So what is present in this address, it will give us output as a plus 3, and the a plus 3 here is 4092. So it will give me 4092, okay. Now we are doing asterisk ptr, right. So asterisk ptr means what is present in this address, okay. First we dereference this address, then we are dereferencing this address, right. So what is present in this address, it is 40. So it will give me output as 40. So this will give us output as 40, and our final output will be 140, right. Now let's see another question. So we have our second question now, in which we have to find the output of this line, right? So the program execution start from the main. So first of all, 4 variables are defined. Let's say these are A, it will be having some of its own address, then there is B, then there is C, and then there is also an D, and the contents are 2016, and then it is 0, and then 4, and also 42, right? Now it is written, it is calling the function and sending the addresses with the call by reference method. Okay, so here PTR and PTRB are declared. Basically we can define, or we can write this sentence into 2 parts again. The first part can be like int asterisk PTRA, and then PTRA equals to end of A. Okay, so 2 addresses are there, or 2 variables are there. Let's say it will be having address of its own, and now since these are pointer variables, they will be holding the addresses, right? So this is PTRA and it is currently holding the address of A. Similarly, there is PTRB which is holding address of B, right? Now it is calling, so control will go, and another pointer variable is declared here with the name temp. So temp will also be holding some address, right? Currently it is holding the address of some garbage location. Then it is written temp equals to PTRB. So temp will now hold the PTRB, which means it will be holding the address of B, right? So it will be holding address of B right now. And then PTRB is assigned with the PTRA. So PTRB will become equal to PTRA, or we can write here PTRB is equal to P, or we can write here end of A, right? Then PTRA equals to temp. So this address will now be holding the address of B, right? Or I can also write here temp. Whether I write here temp or and B, both are pointing to the same memory locations, right? Now the function is closed, and then it will be written back. Now it is written if A is less than C. Now in anywhere in the function call, the value of the actual variables are not changed. Okay, only the addresses are the shift between the temporary variables, we can say, with the name PTRA, PTRB and temp. Okay, but the values, actual values holding by those variables are not changed. So currently A is holding the value as 2016, and then C is holding value as 4. So is this condition is true? No, it is not, as 2016 is not smaller than 4, right? This is false. So this will be false, this line will not execute, and then it is again calling the function with the address of end of A and end of B. Now the same type of operation will be performed, but the actual values will not be altered or changed. Then it is written %d/n_a. Okay, so main value is never changed, and it will give us output as 2016, right? So this was about this question, and the output will be 2016. Now let's look at the final question for this video, in which we have to again find the output of this line. Now first of all, it is written int I equals to 5 and j equals to 10, which means 2 memory locations are given, and then let's say the address is end of I and end of j, and the contents currently it is holding it 5 and 10, right? Then the function is called with call by reference and call by value mixed together. Okay, so in the first variable, P is holding the address of I, and then M is holding just the value. Okay, so there is P and there is M, right? End of M, and there is also end of P, right? So P is currently pointing to this location. Okay, let's say if the address is 4090, so if I do here printf of %u and P, then it will give me output as 4090. Okay, inside it, if I write here printf %u and then write here P, then it will give me output as 4090. Now basically P and end of I are pointing to the same memory location, remember that. Okay, and M is completely a different variable. It is holding just the content of J, so it is just holding the value of J, which is 10, right? Now it is written M equals to M plus 5. So M equals to M plus 5, which means the value will be added by the 5. So this will become 15, right? And then it is written asterisk P equals to asterisk P plus M. Now P means 4090, okay, or P means this location. Now asterisk P means whatever is present in this memory location. So what is present in this memory location? 5, right? And now it is saying, this line is saying, change whatever is present in this memory location with the previous value and add m value of m in it. So it means that whatever is present, let's write the line first, m. Okay, so whatever is present here, which was currently 5, and then the current value of m, which is 15, right? So asterisk p should be now 20. Okay, so the value whatever is present in this address is changed, so this will become now 20, right? And then it is written return keyword. Okay, so the control go back here. Now it is written I plus j. So basically the value of I has been altered here with the content of 20 now, and j is 10, right? So 10 plus 20 will give us output as 30, and this will be our output. Okay, so I hope you get the idea here. Both are, remember that both are pointing to the same memory location. Okay, there is some memory location, and whether I access is using AND of I or P, both have the same meaning. Okay, so I hope you like the video. If you have any doubt, please comment it down. Thanks for watching, and I have to see you in the next video with some new questions.